Okay. Good afternoon, students. Whether the screen is visible?
Yes, ma'am.
Okay. So we are going to start with the next practical. So which practical we have covered last time? Circle generation was over, no?
Yes, ma'am.
Okay. So today we will start with 2D transformations. Okay. So let us see the code for 2D transformations. So as usual, first of all, let us revise what are the 2D transformations. So in 2D transformations, we have seen the translation, rotation, and uh, scaling and reflection. So these four transformations we have learned in two-dimensional objects. So first is the translation. So translation is nothing but changing the position of the object. So just shifting the object to a new location is nothing but your translation. So here the object size and shape is not going to change. Only we are going to shift the object or simply picking up the object and dropping it into the other location is nothing but your translation. And this translation takes place in a linear way. So in a line, in or in a straight line, this translation takes place. So the movement of object is um, according to a straight line. So in the straight line path, the object is moving. So that is called as translation. For this translation, we have used a matrix where the dx and dy, that is, or tx and ty, that is the translation factor along x-axis and translation factor along y-axis. So they are getting added in our original coordinates x and y. And you are getting new parameters as the translated object like that. So the translation is nothing but shifting of the object. Then we have seen the rotation. So rotation is nothing but it is again change in the position of the object only, because the dimensions of the object are not going to change by using the rotation. Simply we are going to rotate the object. That means we are going to change its coordinates to a new location, but the path is circular path. So the pivot point we have seen, that is nothing but the origin with respect to which you are rotating the object. So pivot point or the origin is one point around which the object is getting rotated. Then we have seen for rotation you required angle of rotation. So here also we are going to accept the angle of rotation from the user side. And in terms of cos theta and sin theta, you have developed the T matrix. If you remember rotation T matrix, so the direction of anticlockwise rotation is considered as positive, right? So counterclockwise rotation or anticlockwise direction is considered as positive for rotation, right? So that much part about rotation. If clockwise direction is there, then we are considering the angle to be negative, and that's why we are changing the sign of sin theta, right? So row become column and column become row. That is nothing but the transpose takes place for T matrix. So that is about the 2D rotation. Then we have seen the scaling. So scaling is nothing but now first two transformations we have learned that was only shifting the position of the object. We are not changing the size. of the object. And scaling is nothing but we are going to change the size of the object. Either we are going to expand the size or we are going to compress the object. So expansion is done if the scaling factor Sx and Sy, they are greater than 1. We have seen that if Sx and Sy are greater than 1, then we are finding scaling taking place. So it enlarges the object. And if that scaling factors Sx and Sy along x and y direction, they are less than 1, that is 0.5, then we are getting compression in the object. And if both the factors are equal to 1, then we are finding that there is no change in the object. Okay. Then we have seen the uniform and non-uniform scaling also. So in uniform scaling, the scaling factor along x is exactly equal to scaling factor along y. So Sx and Sy, they are equal. That is called as uniform scaling. So whatever the change we are doing along x-axis, the same change is reflected along y-axis also. So that is called as uniform scaling. And if these two factors are not matching, then we are calling it as a non-uniform scaling. So in that case, somewhat change in the shape of the object you can find. But in uniform scaling, there is no change. Only the size is changing, but actually the shape of the object is not going to change. But in case of non-uniform scaling, the shape is also changing. Then we have seen the fourth transformation, that was reflection. So in reflection of the object, we have seen there are 4 kinds of reflections in two-dimensional object. First is reflection along x-axis, reflection along y-axis, then reflection along y equal to x and y equal to minus x. So here the coordinates are not going to change, only the magnitude is not going to change, only the sign is changing. So if the reflection along x-axis is taken, then y becomes negative. If reflection along y-axis is there, then x becomes negative. If y equal to x is the axis, then simply interchanging x and y. And if y equal to minus x is the axis, then along with interchange, sign is also changing for both x and y. Right? So these are the T matrices for 2D reflection. Okay, so that is just the revision part of the theory. So now we are going to see the practical. Okay, is there any difficulty up to this? All of you have revised the concepts? Yes.
Yes, ma'am.
Okay. Boys side?
Yes, ma'am.
Yes, ma'am.
Okay. Right. So let us start now the code. So first, as usual, these files are header files included in that math.h, graphics.h and dos.h are there. Then in the main program, you are having graphics driver and graphics mode initialization. So you are initializing them as integers. Then we are having these parameters x1, y1, x2, y2, x3, y3. So these parameters are required to accept the object because your object is a two-dimensional object and we are going to see whether the transformations are there on this object, and that's why the coordinates of object are these. Then tx and ty are the translation factor along x along y. Then choice is taken because here all the transformations I am using here switch case for that, and the choice is entered according to the transformation you want to do, and that's why here choice is taken from user side. Then C is also one choice, which is internal choice that we will see. That is a variable considered. Sx and Sy scaling factor along x and y. x4, y4 required sometimes, and shx and shy are the sharing factors. So this part we have not covered yet. Okay, so we will see the first 4 transformations only today, and the 5th transformation in the next practical. Then these are the double variables required to perform maybe scaling. That is, if I'm compressing the object, then the fractional number you will be getting, and that's why here the double variables are considered. Then init graph is the command for initializing graphics output screen. GDGM are the handles, and BGI folders you have to pass. So which will begin the graphics interface. Then here normal printf statements to display the menu. So total 5 items are there, or 5 menus are there in switch case. And here you have to enter the choice. So that choice is accepted with ch variable, right? Then I'm using here switch case depending upon the choice entered by the user. So here you are entering the choice, you are taking the choice from the user. Depending upon that choice, the switch case is applied. So in the switch case, choice number 1 is translation. So let us see what translation does. So in switch case number 1 is translation. So I am going to accept the values for the rectangle. So rectangle is considered as a 2D object on which I will be doing the translation process. So here x1, y1 and x2, y2 are accepted as the rectangle parameters. So it is nothing but the left, top, right and bottom boundary. All of we know how to draw the rectangle. So it requires only 4 parameters to draw a rectangle. So these parameters are accepted, and then I have to take the values of tx and ty. That is nothing but the translation factor along x and translation factor along y. So once I get those things, I will draw the rectangle with the original one first. So that will be your original object x1, y1, x2, y2. So with these 4 variables, I will draw first rectangle, and then by performing addition of tx into x1, x2, that is the translation along x-axis, tx is the factor, and add ty into y1 and y2 respectively. That is nothing but your translation factor along y direction, and then again display that resultant rectangle. So that will give you transformation, that is addition of tx into x and addition of ty into y. So once the resultant rectangle is displayed, once the resultant rectangle is displayed, I am using here get ch, and then break is applied. Then break is applied. Okay, so this is your case number 1, that is called as translation. Okay, is there any difficulty here? Okay, so let us compile the program and execute it. Okay, so all of you are able to view the menu displayed. So here I will enter the choice number 1. 1 is entered. Then it is asked the value of the rectangle. So the values of the rectangle I will be putting, that is 10, 10 is the first, or instead of 10, 10, I will write 40, 40 so that it will be better visible. Otherwise 10, 10 will be the corner of the screen only. So 40, 40 is the left bottom element, and top right element may be 100, and let us say 60. Okay. So this is your rectangle. Now Tx and Ty, that is nothing but the amount by which you are going to shift the object. So let us take 50, 50 is the Tx and Ty values. So this is the rectangle before translation. The 40, 40 is the upper left corner, and lower right corner is the 100, 60. And then when I press enter, I will be getting the rectangle after translation. So this rectangle is shifted 50 units towards positive x-axis and 50 units towards positive y-axis. So that is called as 2D translation. Okay. Is there any difficulty in 2D translation? Girls, all of you are understanding?
Yes, ma'am.
Boys?
Yes,
Yes, ma'am.
Okay. So let us move to the next transformation, that is rotation. Okay. So rotation is your choice number 2. You can see here. The choice number 2 is rotation. So whenever choice 2 is entered, it will enter into the switch case number 2, and it will start doing the next thing. So it will ask for the choice. So why choice is taken here? So because there are two possibilities of rotation. First is the clockwise rotation and other is anti-clockwise. So that's why the choices are taken for clockwise and anti-clockwise rotation of the object. Okay. So here the 2D object considered is line. Earlier we have seen the rectangle. Here for rotation, the line is considered. So here the choice is taken from the user side for clockwise or anti-clockwise rotation. Then we are printing the line before the rotation. So accept the coordinates x1, y1, x2, y2 from the user side. Then draw the original line. So by using the line command x1, y1 to x2, y2, we are able to get the original line. Then after that, I will ask for the angle of rotation, because whatever may be the choice, clockwise or anti-clockwise, the angle of rotation should be given, and that is accepted in D1. Okay. So it is the D1 variable which is accepting the angle of rotation. Next is according to the choice, whether it is clockwise or anti-clockwise, the choice is taken. So one indicates the clockwise rotations. So see here, the one choice indicates the clockwise rotation. And case number 2, that is choice number 2, indicates the anti-clockwise rotation. Now consider here whatever the sine and cos functions are there in math.h. So math.h is a header file which will support the mathematical operations in Turbo. So here, this math.h file is using the sine and cos, but here the angle is not in degrees. The angle in the cos and sine functions are considered in radians, and that's why here the angle should be converted into radian. And to convert the angle into radian, what you have to do is you have to multiply it with pi by 180, right? All of you are aware that converting the angle from degree to radian. So the user will provide the angle in degree, and that should be converted into radian. And for that, the formula is multiply it with pi by 180. Now, once you get that radian angle, then pass that into cos and sine function. So cos and sine function, they are inbuilt functions supported by math.h. So these are the formulas to calculate the new parameters x11, y11, x21, y21. So these are the new parameters you are getting after rotation, right? So how these things are done? We are having the uh, 1 second. We are having that okay. So let me use whiteboard to explain that. So all of us know that for any line, so if I am taking the line and I want to rotate it with respect to the origin, then I should know the angle direction of the rotation, and I should know the angle theta for the rotation. So here also we are getting those values in terms of choice. So direction is considered as choice number 1 and 2, that is clockwise and anti-clockwise, and theta is accepted in D1 parameter, and that D1 is converted into radians. Okay, now we are having the D1, that is radian angle with me. Now what is our T matrix? What is our T matrix? Anyone is remembering? Okay, so we are having the T matrix as cos of theta sine theta minus sine theta and cos theta. This is the T matrix. And when we multiply the line coordinates with this T matrix, suppose this line is having coordinate x1, y1 to x2, y2. So these are the coordinates x1, y1, and for this point, the coordinates are x2, y2. So I will be using here x1, y1 and x2, y2 over here. And when I perform the multiplication between them, I will be getting the result as x1 cos theta minus y1 sin theta. This is the new value of x. So I will call it as x11. Then y11 is nothing but multiply this first row with second column. So y11 is x1 sin theta plus y1 cos theta. Okay. Similarly, x22 and y22 or x21 and y21. So what will be the formula for x21? You have to multiply the second row with the first column. So x2 cos theta, x2 cos theta minus y2 sin theta. And x2 sin theta plus y2 cos theta. Okay, so this is the formula for calculating the new parameters in rotation. So the same formulas are used. So let us see whether the same formulas are used. Okay, so the formula for x11 is x1 cos theta minus y1 sin theta. So let us see it is same or not. So it is, you can view here now in program. It is x1 cos theta minus y1 sin theta, right? So same way here, the x11, y11, x21 and y21 are detected by performing the multiplication of original parameters into T matrix. So once this is done, it is giving you the new parameters x11, y11, x21, y21. Then comes the so now the parameters are with us. So now it is our turn to display the line. So line after rotation is, by using this line command, we can display that line. Now why here the integer is converted, type conversion is taking place, right? If you see here the integer, it is using integer like that, because this x11 is defined as float, but the line function accepts only integer parameter. It is the syntax of the line function supported by graphics.h, that it accepts only integer arguments or integer parameters. And that's why the type conversion is required. So x11 will be converted into integer, because earlier x11 is considered as the float number, long float. Okay, so that is how you are able to display the line after rotation in clockwise direction. Now in case 2, for anti-clockwise direction, only here the sign is changing. You can see here the sign is changing. For cos it is common, for sine the sign of sine function is changing, and that is only done over here, and the remaining thing is same. For anti-clockwise also, you have to convert the angle from degree to radian, then use that radian angle to calculate the x11, y11, x21, y21, and then display the result by using the line function. Okay, is it clear? Yes, students?
Yes.
Okay. So once case 1 and case 2 are over, the next part is simply you have to break this inner switch case as well as the outer switch case. Okay. So let us compile and run this code. Now choice number 2 I will be using. So in choice 2, I will be accepting the new choice, that is whether the clockwise rotation is required or anti-clockwise rotation. So let us have the clockwise rotation only. So line before rotation, you have to pass the parameters. So passing the parameters, let us say 40-40 to 70-40. How this line will be? Can you imagine how it will be? Where it will lie? Obviously, it will lie in the first quadrant, but this line will be horizontal. So you can see that horizontal line, 40-40 to 70-40. Now I will have to enter the angle of rotation. So let us rotate it with 90 degree to check whether our program is working accurately or not. Right, because after 90-degree rotation, it should be vertical. Right. So Okay. Okay. So can you tell me why this line is not getting displayed? See here, we are actually displaying the line in the first quadrant itself, right? Because the whole screen is acting as your first quadrant, X positive, Y positive. But when I am taking 90-degree angle, what is the cos 90? Cos 90 is 0. And this 0 into x1, it will become 0. And minus value will give this result as negative. So x value will become negative. Maybe y will be positive. Then again, here also x2 also becomes negative and y may be positive. So x negative and y positive is your second quadrant. And as it is second quadrant, we cannot display it here because the whole screen is acting as your positive, that is first quadrant. So I have to make some modifications over here that divide the screen into 4 quadrants, and then it is possible to display the line. Okay, so I will do those modifications here. Get max x by 2 plus x and get max y by 2 minus y. Get max x by 2 plus x and get max y by 2 minus y. Similarly, the line should be when I will display the original line, at that time also you have to do these things. Otherwise, your original line will be displayed according to the first quadrant. And get max x by 2 plus x1 and get max y by 2 minus get max x again get max so this is your vertical axis which is running from 0 to maximum y and half of the x. So half of the screen, the vertical axis is this. And in the line function, I will have get max 0 get max, sorry. It will run from 0 value of x and y by 2, comma, get max x, comma, get max y by 2. Okay. Okay. So I have done some modifications over here. Now I will run the program. Let us see whether I can get the output now. So the choice is second, new choice is 1, line before rotation is 100 to 200 horizontal line again. Correct? Okay. Let me check. Something is mistake. The program. The horizontal vertical lines are okay. Original line is get max x by 2 plus x, get max y by 2 minus y, get max x by 2 plus x, and get max y by 2 राहिला. Okay. 2 minus y2. Okay. Okay. Let us run the program again. 2, 100 to 200. Okay. Now I am getting the line which is horizontal. And now if I put the angle of rotation is 90 degree. Now this rotation is carried out with respect to origin, right? If you remember, although the rotations are carried out with respect to origin always. So here is the origin and the rotation is carried out. And after rotation, you will find the line in second quadrant. Right? Where is that line? Okay, so the earlier line is also coming on the axis itself, and that's why we are not able to view that. So now I have changed the color of the line, and we can view that line which is lying on the x-axis, blue color portion. Okay, so earlier also the line was horizontal, and after rotation. So now let us have the same uh, line again, and we will see the whether it is giving you the output or not. So choice is 2, new choice is 1. The line before rotation is, let us say, 50-50. Horizontal line we will take. And now I will rotate it with 90 degree. So angle of rotation is 90. Somewhat it is giving you the wrong answer. Let us see. It should be vertical. Okay, but for remaining examples, 2, the choice is second. The line before rotation is suppose 40, 42, 100. The slanting line, when I will rotate it with 45 degree, then it is showing you the horizontal, because this line is y equal to x-axis, 40, 40 and 100. So this is your already the slanted line is 45 degree line. So when I still still rotate it with um, 45 degree more, then it will be lying only on axis itself, x-axis. So you can see that it is lying on the x-axis. So maybe due to this type conversion, some fractional part is getting missing. That's why some distortion you are observing in the line. But otherwise, we are getting the output in the proper way. So this is your choice number 1. We will have the anti-clockwise rotation. And here it is clockwise. Yes. So anti-clockwise rotation, we are finding it out. Okay. So due to this rounding off only, some minor changes are taking place in the coordinates maybe. Otherwise, the remaining code is okay. There is no issue. We will execute this once again. Okay. So we will leave this. I will correct, I will modify the code and I will send this to you. For rotation of the object, it is showing somewhat error. So I will find it out and correct it. Okay. Then we will see that once again. But otherwise, the steps behind this is same, that you are having the T matrix like this. You have to multiply with the cos theta sin theta and minus sin theta cos theta if the clockwise rotation is there, and for anti-clockwise this is the rotation. Okay, so in short, these calculations I will check and I will give you the correct running program. Okay, so for today's session we will stop here only, and in the next turn we will start with this execution again. I will give you the correct code and then we will see the case 3, that is scaling along X and Y. Okay, so we will stop here for today. You just give me attendance. Roll number 1.
Present, ma'am.
Roll number 2. Roll number 2 is there? Roll number 3.
Present, ma'am.
Okay, roll number 4. 5.
Present, ma'am.
6.
Present, ma'am.
7. 8. 9.
Present, ma'am.
10. 11.
Present, ma'am.
12.
Present, ma'am.
13.
Present, ma'am.
14.
Present, ma'am.
Okay. So only roll number 7, 8, and 10 are not there. Okay. 7, 8, 10. 2 and 4. Okay. So you may leave now. Thank you. I will provide you with the correct executing code.